This lesson is 1.7 today. We're going to look at square numbers. Now, it will really help you on this one today if you think back to 1.2. And if you can't remember what 1.2 was about, go back out into Blackboard and download and watch that video again. But 1.2 was about rectangular arrays. And I hope you remember the old rule about how a rectangle and a square are really, really closely related. In this situation with a rectangle, you should notice that a rectangle has two sides the same length, these two, and the other two are the same length, whereas a square has all four sides the same length. And that's kind of the key here. We're going to be looking for numbers who make squares. We're not going to be looking for rectangular numbers today. We're looking for square numbers. And if you think about rectangular arrays and drawing dots, you're going to see a pattern develop, and hopefully it will make sense here. What I want you to do when you get to this is practice. Draw some square arrays, not a rectangular. Remember I talked about rectangular arrays. But a square is a rectangle. But we know a rectangle is not a square. So even though squares are part of the rectangle family, not all rectangles are square. So we've got some arrays drawn here. This one right here, this one is not a square array. This one has one side of 3 and one side of 2, and 3 times 2 would get you 6. This is not a square though, this is a rectangle. So what we've done is we've kind of drawn some of the square arrays. This is a 1 by 1 array, a 2 by 2, 3 by 3, 4 by 4, and 5 by 5. Now, all 5 of these arrays are square arrays, and what that means is the one side is the same length as the other side. This side is 5 dots, this side is 5 dots. Now, if you were to do the math here and multiply the sides together, you would get this one is 1, this one is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. Square numbers. Here's the definition. A square number is the product, that's the answer, of a number multiplied by itself. In other words, if you take any number and multiply it by itself, you get a square number. That's what would be right here. So you can look at some very simple ones. You pick a number less than 10. For example, 3. 3 times 3 is 9. 9 is the square number because it's a number times itself. 5 times 5 equals 25. 25 is the square number because it's a number times itself. So that's what we're looking at here. We're talking about square numbers. Knowing your multiplication facts, again, will help you tremendously on here. Because we're going to get pretty big here. We're going to get with some big numbers. 10 times 10 is 100. And 12 times 12 is 144. These two are both square numbers. Now, if you're not sure if a number is a square number or not, like for example 81, you would write out the factors. And you would think, well, 1 times 81, 3 times 27, and then you have this single digit right here, 9. What you have to understand is 9 times 9 equals 81, so that would make this a square number. So if you set up your factor string like this, and if you have one lone digit, then that number times itself will get you this number, then that makes this number a square number, E1. Now, in this chapter, you're also going to be exposed to exponential notation. Exponential notation is a little different. A lot of kids want to do something that is wrong that you need to get out of the bad habit of, but a little definition here. Exponential notation is based on two things. You have a base number, which is this number right here, and then you have a little tiny number written up in the corner, and that is the exponent. Now, why we use exponential notation we'll explain later, but it's basically a way to save space when you're writing large numbers. 5 times 5 you should know equals 25. But another way to write this would be 5 to the second power. 5 of your base, exponent 2. Now here's the bad thing. A lot of kids will see this and think in their brain that that means 5 times 2, and they are going to say the answer is 10. But that is not correct. What you have to understand is this is 5 times itself 2 times. There's 1 5, 2 5s, an exponent of 2. And that's 5 times 5 equals 25. All we're worried about for right now is an exponent of 2. Later on, we'll see bigger exponents, but that's not our concern at this moment.